Hello and welcome to this lesson, Loops in PineScript. This lesson consists of following sections. In the first section, we'll study a role of loops in TradingView PineScript. After that, we'll study when to use loops in PineScript and when they are not needed. And in the last two sections, we'll study for and while loops in PineScript, the syntax, and we're gonna run through some code examples. So let's begin. So in the area of TradingView PineScript, the necessity of loops depends on the efficiency and functionality of your code. In this lesson, we'll dig into scenarios where loops are not needed and the instances where they are absolutely necessary for effective scripting. So when loops are not needed, the PineScript runtime and the built-in functions render loops unnecessary in various situations. Let's explore examples where loops can be avoided for more streamlined and efficient code. So let's review this example. Some beginner programmers might attempt to calculate the average of the last 10 close values using loop, like in this example. However, this is inefficient. Let's review this code. In this code, we see that we have a loop that starts from 0 and runs until ma length -1 until 9. So loops runs for 10 times and it calculates summary of close price for the last 10 bars. And then it calculates average of this close price. So there is a more efficient approach to avoid this loop and calculate the same average of the last close price for the last 10 bars. And this approach is presented in the next code example. Here we use ta.sma function to calculate simple moving average of the close price for the last 10 bars. This way we avoid loop, we avoid using loop and executing and calculating the same value. Average price of a close for the last 10 bars. Now, counting the number of up bars in the last 10 bars is another task when deemed suitable for loops by beginners. However, a loop is not needed. So let's review the following code. So in this code, we have a loop that iterates for 10 times. And inside of loop, we check if close is bigger than open. In other words, if it's an up bar, then we add 1. We add number of up bars by 1. So we calculate number of up bars from the last 10 bars. However, this code can be calculated, can be developed more efficiently, and this iteration can be avoided. This loop can be avoided by using different approach. So in this more efficient version, what we do is we use ternary operator to create an expression yielding 1 on up bars and 0 on other bars. The function math.sum maintains a running sum of that value for the last 10 bars. So this way we avoided the loop and we do exactly the same calculation of calculating the number of up bars for the last 10 bars. Now, let's review when loops are necessary. While loops can be often bypassed, there are still some scenarios where they are crucial for effective Pine scripting. First case, when manipulation of collections. So you can use collections and you want to sum, you could want to manipulate them, do certain calculations within those connections. Loops become essential when dealing with collections like arrays, matrices, and maps. Second case, looking back in history. When analyzing bars using a reference value only known on the current bar, such as finding past highs higher than the current bar's high. Another scenario when you need to do complex calculations on past bars. Certain calculations on history bars may demand loops when built-in functions fall short. So, in conclusion, knowing when to use loops and when to skip them is important for creating efficient PineScript code. When you're working on your script, think about the task you're trying to accomplish to choose the best method. Now let's study for loop and its syntax. The for structure in PineScript allows repetitive execution of statements using a counter. In other words, the for loop is a control structure that allows you to execute a set of statements repeatedly based on a counter. The syntax of the for loop is as follows: declaration, type, identifier, equal sign, for, identifier, equal expression to expression by another expression, and local block loop, where declaration mode is a variable declaration mode and it is optional. Type is a variable type, it's an optional also. Identifier is a variable name that serves as a loop counter. And the expression is initial, final, and step values for the loop. The for loop iterates through a range of values specified by initial, final, and step expression. So it iterates starting from initial until final by the step. The loop executes the statements within the local block loop. So this statement is being executed during for loop iterations. So let's now review a simple example of the for loop that prints number from 1 to 5. What we have here is 4, and we have I as an identifier that starts from 1 until 5, and on each of these execution we plot this I identifier. We have here, as you see, 5 iterations, and for each iteration we plot this value of I identifier. So this is how the loop works in this example. So you can also use by keyword to specify a step other than 1. For instance, for I equal 1 to 10 by 2. In this case, you would add another keyword by, and you would specify the step for the loop. It's important to note that PineScript's for loop is often used when dealing with historical data or performing repetitive calculations that involve iterating through a range of bars. So here, more practical example where for loop is used to calculate the sum of closing prices over last 10 bars. Here we have a loop that starts iterating from 0 until 9. So, and it calculates the sum of the last 10 closes. So it keeps adding the close to the variable sum of closes for the last 10 bars. And after that, it plots that summary. So understanding the for loop is important for efficiently iterating through tasks that require repetitive execution. Now let's study while loop. The while structure in PineScript allows for the repetitive execution of statements until specific condition becomes false. We'll study the syntax, use cases, and examples of while loop in PineScript. The syntax of while loop is follows: declaration mode, type, identifier, equal sign, while, expression, and local block, where declaration mode, variable, declaration mode, type, optional, variable type, identifier, variable name, equal, and after that expression, it's a condition evaluated at each iteration, and local block loop, statements executed within the loop. So some key points needed to be mentioned here. Evaluation of the condition happens before each iteration. It means that before each iteration and before executing the local block loop, expression is checked. And if expression is false, even before first execution of the local block loop, the local block loop is never going to be executed if initial check of expression is false. Changes to the condition inside the loop impact the next iteration. So inside of this while loop where local block loop is executed, some changes normally happen in certain variables that affects the expression that is calculated before next iteration. The loop stops when the condition becomes false. The condition is within this expression. Now let's review an example of counting bars with while loop. So here we're counting bars if for the certain bars back, in this case we set it default number of bars to 50, and we calculate the number of bars which are higher than current high for the last 50 bars if we use default values. So we count higher bars, and then we count if those high are lower than current high. So we in other words, we calculate number of higher bars and number of lower bars comparing to current high. So, and we basically iterate here for 50 times, because default value for look back input is 50, but could be more if you change this parameter. So basically this is an example how while loop can be used. So in conclusion, for while loop, it is important to know when to use while loops for effective PineScript coding. These loops are valuable for repetitive tasks until a specific condition is met, providing flexibility and efficiency in script execution. In a nutshell, understanding loops is a big deal when you're scripting in PineScript. Sometimes you don't need loops because PineScript has shortcuts like built-in functions that get the job done faster. For example, calculating averages or counting things can be way more efficient without using loops. You can rely on built-in functions such as ta.sma or math.sum for smoother and quicker scripts. But loops still have their bright moments in PineScript. They come in handy when you're dealing with collections, digging into past data, or tackling complex calculations that need a more hands-on approach. So knowing when to loop and when to use shortcuts like built-in functions let you create PineScript that are both efficient and effective, matching the needs of your project. This is the end of this lesson, and I will see you in the next one.